Hello, today's lesson is looking at how you can represent journeys graphically using distance time graphs. The starter activity here is just reminding you of what you've done previously, the different speeds of different objects. So walking 1.5 meters per second, average speed of sound in air around about 330 meters per second. You do have to remember these, so please take some time to test yourself, and it's in meters per second as that is the standard unit of speed. There's also a YouTube link for you here to watch when you have time. Okay, so this is what you need to know to construct or draw distance time graphs, to determine, so that means to work it out, the speed from a distance time graph, and for higher tier, use a tangent line to determine the speed of an accelerating object. Accelerating as in the speed is changing, so we will come on to do more about that in the upcoming lessons as well. So, how can we represent a journey with a distance time graph? This image here is from an app like Map My Ride showing a cycle journey. You've got the distance here, the time taken, and then the average speed by dividing the total distance by the total time. When you're drawing your graphs, you use them to describe the motion of an object. So the time goes along the x-axis and the distance along the y-axis. We're going to look at distance time graphs in more detail. Let's just have a look at the rules, what each part means. So that's your next heading, rules for distance time graph, and these are your notes. So your gradient gives you the speed. If it's straight uphill, it means the object is travelling at a steady speed. The steeper the slope, so the steeper the gradient, the faster the object is travelling. Flat sections means the object is not moving, it is stationary. Curves tell you whether the object is speeding up, accelerating, or slowing down, deceleration. If it's curving up, a steepening curve, it's accelerating. If it's flattening a curve, it is decelerating. So you might want to pause the video now and copy these notes into your notebooks. So here's a distance time graph. I'd like you please to copy this, just a sketch, because we're going to go through each section. You might want to turn your book around landscape so it's big enough for you to add some notes as we go along. So if you pause the slideshow now, and then we can carry on adding some notes once you've done the diagram. Okay, so this part of the graph here is the linear section, and the object is travelling at a steady speed. And you can calculate the speed by finding the gradient. So the object has travelled a distance of 200 meters in the time of 20 seconds. So if you were to draw the gradient in here, you would have the change in y, 200, divided by the change in x, 20. So 200 divided by 20, the speed is 10 meters per second. This next bit of the graph here, the object has not moved any distance. It's still at 200 meters, but the time has passed from 20 to 40 seconds. So the object is stationary, not moving. The next section is a curve, which is increasing up here, and so we say the object is accelerating. This curve, however, is flattening, so the object is slowing down or decelerating. This final part of the graph, the object here, the line here, is again a linear section. However, the gradient isn't as steep as the first part. So that object is still travelling at a steady speed, but it is a lower steady speed than this part of the journey. I'd like you to pause this slideshow now and make a sketch of this graph in your book. And the important thing is to make sure you know what each section is showing you, because when we come on to do velocity time graphs, you'll have the same sections in the graph, but they will mean different things. This next slide shows you how to calculate the speed of an accelerating object at a certain time, and it is higher tier only, so you'll need to look at this one. So if you could make a sketch of this graph and copy the notes into your book. So for example, you want to find the speed of an object at 25 seconds. So what you need to draw is your tangent line, shown here in red. And they are quite difficult to draw. It just needs to be touching the curve just here at 25. So also what the trick is to make this line as long as you can. And once again, you're going to find the gradient. So your change in y, so here is up to from 0 to 170 from this graph. So that's your change in y, and your change in x is 35 seconds, take away 15. So here's the calculation here, 170 take away 0, divided by 35 take away 15. So then you end up with 8.5 meters per second for the speed of the object at time 25 seconds. Like I said, tangent lines are really difficult to draw accurately, so don't worry if when you draw your graphs you get a slightly different answer. As long as it's reasonably close to this answer, and when you have drawn your tangent line in, whoever's marking your work can see where the tangent line is going, then that would be fine. These next set of slides are questions for you to practice. Please have a go first and then look at the answers to green pen them. This slide here, it would be really good if you could have a go at drawing your own graph from these results here. Plot the values, join the points on a distance time graph, and then you can answer the questions. One thing to point out is when you plot your points, use crosses, remember, not points, plus graph paper, pencil, no pens. This one is a bit more complicated, so plot your graph and then have a look at this mark scheme here, because you've got to draw a tangent line and work out change in y divided by the change in x.